Okay, in the next example, non-homogeneous differential equation, in case number 2, where the fx, okay, is in the form of exponential function, the same thing as before. So in this example, we need to solve a particular solution. We need to find a particular solution, okay, to this second order differential equation. dy dx second derivative dy dx minus 2 dy dx first derivative plus y equals to 6 e to the power of x, which is an exponential function. So just like before, we start with the characteristic equation. Okay, the characteristic equation in this case is m squared minus 2m plus 1, okay, equals to 0. Okay, we will ignore our non-homogeneous terms at the moment. Okay, let me just highlight. Okay, this is our non-homogeneous terms, which is fx. We will do that later. Let's focus on the characteristic equation. So again, if you check the b square minus 4ac, you will get the value to be equals to 0, which means we have equal and roots. Okay, equal roots, which is in this case, we just write down, okay, m 1 1, both of the minus to get minus 2. In other words, our roots, okay, our roots m1 and m2 equals to 1. Okay, so just like in the previous lectures, okay, if we're dealing with equals roots, okay, same roots, then our complementary solution, okay, yc will be in the forms of, okay, I can use the letter c1 plus c2 x times e to the power of, okay, mx. M is the root, m representing the roots. So we have the value of m already. So our yc equals to c1 plus c2 x times e to the power of x, basically 1x. Okay, or you can say c1 e to the power of x, okay, plus c2 x e to the power of x, same thing. So this is our complementary function solution, yc. This, okay, as well as this, okay, equals to our yc. Now we look at our non-homogeneous terms, okay, which is fx. Our fx in this case is 6 times e to the minus x, to the power of x. So in other words, because it is exponential, we can expect the solution suggesting that solution yp is in the form of x to the power of r times k, a constant, times e to the power of x, okay, which is the same power as the question in mark. So this is e to the power of x, and then this is also e to the power of x. Make sure it is the same. So the coefficient is 1, constant 1. So we start with our r value. Okay, if r equals to 0, then our yp becomes x to the power of 0 times a constant e to the power of e to the power of x, which is basically equals to k times e to the power of x for yp, and just like before, we need to check, okay, compare terms in both yp and yc. Okay, so in here our yc, okay, is the same as this one. That's a yc the same as this one. Okay, therefore we cannot use r equals to 0. So in this case, I just write down k times e to the power of x is the same as c1 times e to the power of x. Okay, so and this is in yp, and then this is in yc. Therefore cannot use r equals to 0. So if r equals to 1, then yp equals to x to the power of 1 times a constant times e to the power of the same constant, exponent, and this equals to kx times e to the x. Okay, in this case we still have problem because kx times e to the power of x is the same as these terms in our yc. So in this case cannot use r equals to 1 because let me just write down, okay, because the kx e to the power of x correspond to c2 x to the power times e to the power of x. So in this case, this one is from yp and this one is from yc. So we need to go up further. If r equals to 2, then yp becomes x to the power of 2 times k times e to the power of x, which is k x square times e to the power of x. Okay, now this one, there is no corresponding terms in yc. Okay, in this case I just write down no corresponding terms in yc, so we can proceed. Therefore, okay, we can conclude in this case our choice, okay, our yp is k x square times e to the power of x. Okay, let's just highlight that. So we got our yc and we also got our yp. Next we need to take the derivative, okay, of our yp. The first derivative is, okay, with respect to x, this one will be product rules. Okay, so we can take out the k first, okay, and then take the derivative of x, the first term. It will be 2x, and then maintain e to the x plus, okay, and this second, guys, 2x times e to the x plus, and then maintain the x square, take the derivative of e to the power of x. So this one becomes, okay, we can take out the e to the power of x, we can take it out, times 2x or x square plus 2x. This is our first equation. Now we just repeat that. Okay, and then take the second derivative of yp with respect to x. So again, we will have to use product rule, okay, between this and this. Okay, product rule. For the second derivative, so again we can take out the k, and then the first derivative e to the power of x, maintain the first terms, and then maintain the second terms, x square plus 2x plus the derivative of e to the power of x, e to the power of x, and then the derivative of the second terms is 2x plus 2, okay, which is same as, we can take out the e to the power of x, so k times e to the power of x, and then the x square plus 2x plus also 2x plus 2. Okay, this become k e to the power of x times x square plus 4x plus 2 to be our second derivative, and therefore we just substitute. Okay, substitute. So this is our second equation. Substitute 1 and 2 into main dE, which is d square y over dx square minus 2 dy dx, which is the main equation, equal to 6e to the x. We will get a very long, okay, a very long sequence, okay, which we can summarize, okay, after rearrangement. After rearrangement, we get, okay, 2k times e to the power of x equals to our non-homogeneous term, 6 e to the power of x, and therefore we can cancel out, okay, e to the power of x and e to the power of x to get k, to get k value equals to 3. So our yp is k, which is 3 x square times e to the power of x. Okay, now we already know that y equals to yc plus yp. Okay, our yc is c1 plus c2 x times e to the power of x plus our yp, which is 3x squared times e to the power of x. Okay, this is our, well, nothing we already know. Okay, this is our yc, and then this is our yp. And we are given initial conditions, okay, at x equals to 0, y equals to 0. Okay, so x equals to 0, we get we get 0 equals to, this is where we will need to calculate our c1 and c2. X equals to 0, e to the power of 0 plus 3 0 square times e to the power of 0. Okay, so you got c1 equals to 0. Okay, and then similarly, if you check on the initial condition here, this is our initial condition. We are given that the first derivative dy dx at x equals to 0, dy dx become 2. At x equals to 0, the second derivative equals to 2. So sorry, this is not the second derivative, but this is the first derivative. The first derivative become 2. So we already know our second derivative. Let me just check, guys, and yeah, this is the first derivative equals to 2. So you can plug it in plug our first derivative, which is dy over dx, okay, equals to, this is the first derivative of our y value, our final y, which is, okay, which is this one, okay, which is this one. Taking the first derivative of that, okay, so in this case we can get dy over dx, okay, to be c2, with respect to x become c2 e to the power of x plus, again we are taking product rules. Okay, guys, let me just write down here product rule, taking product rule in there. Okay, same thing here to get the derivative. So c2 e to the power of x plus, okay, e to the power e to the power of x c1 plus c2 x maintain, okay, plus cx e to the power of x plus 3x squared times e to the power of x. So let me just recap. This is our general solution, which is c1 plus c2 x times e to the power of x plus 3x squared times e to the power of x, and then we take the dy dx from there. Okay, c2x e to the x, and then e to the x c1 plus c2x. Okay, so this is maintaining, okay, this is maintaining these terms, okay, and so on. This is taking the derivative of this one, yeah, and then this one similarly, okay, product rules. So continue. At x equals to 0, the first derivative equals to 2, therefore 2 equals to c2 times e to the 0 plus e to the 0, 0 plus c2 times 0 plus 6 times 0 times e to the 0 plus 3 0 square e to the 0. You get c2 to be equal to 2. So that's it. We got c1 equals to 0 and c2 equals to 2. Therefore, our total particular solution equals to y equals to c2, which is 2x e to the power of x plus 3x squared times e to the power of x, which is a summary of that one, eh? Okay, this one. After working out the c1 and c2 value, okay, to be this one, or y equals to e to the power of x times 3x squared plus 2x, same thing. So that is the particular solution of our second order differential equation.